My name is Tabata. I'm in charge of technical development group of steel company Kobe Steel. Today, I'll explain part two. So, uh, Part two, fatigue crack initiation life of leave to deck welded joints of orthopic steel bridge decks. I'll explain according to the following outline. Let me start by the introduction. In Japan, the number of aging bridges is increasing and it's becoming a social problem. Among the bridges, orthopic steel bridge decks, OSDs, are lightweight and short construction period are widely used mainly for urban expressways. But among the damage cases of steel bridges, the fatigue damages of OSDs is particularly common. When the fatigue damages of OSDs are examined in terms of place, you leave to deck welded joints are the most common. This fatigue damage is caused by cyclic rolling by vehicle passing over the road surface. These fatigue cracks are difficult to visually inspect unless we peel off the pavement, and there is a risk of road caving. So it's desired to suppress the fatigue crack initiation in lift-to-deck welded joints of OSDs in Japanese bridge. In this situation, I'll explain our efforts. We try to solve the problem by applying the developed steel with high crack initiation life. I'll explain developed steel. This steel shows high resistance to crack initiation in heat-affected zone HAZ by adding solid solution strengthening elements such as silicon and copper to steel components. This shows the result of checking the effect of the developed steel in the HAZ. The welded zone are affected by the heat caused by welding, so the property is changed. The fatigue tests were conducted on the specimen cut into small pieces from the developed steel by giving them a thermal history simulating welding. The chart on the right shows a cell diagram. The developed steel has higher fatigue properties than those of conventional steel. So, for the purpose of applying this developed steel to lift-to-deck welded joints, we confirmed crack initiation site and verified effectiveness by application of developed steel. Experimental result and discussion. First, confirmation of crack initiation site. A schematic representation of the test specimen is shown at the bottom. It's composed of deck plate, U-rib, transverse rib, longitudinal rib, simulating OSDs. Materials is deck plate is conventional steel. Strength class is 490 Newton square millimeter and 16 millimeter thick. And U-rib is 6 millimeter thick, and the joints of ribbed deck were welded so that penetration depth becomes 75% or more of plate thickness. Loading method, compressive cycling bending loads and load control. Load range is 15 and 16 kilonewton. This is the result. As shown in the photograph, the fatigue crack was initiated from the HAZ of the deck plate. So the application of the developed steel is expected to suppress the crack initiation of lift-to-deck welded joints. Secondly, verification of effectiveness by application of developed steel. A schematic representation of the test specimen shown at bottom. It's composed of urib and deck plate. In addition, to simulate a transverse rib, we assembled plate to intersect the rib for double-sided field welding. And strain gauges placed at the location shown to measure strain during the test. Materials. Deck plate is conventional steel or developed steel. Strength class is 490 Newton square millimeter and 16 millimeter thick. As explained at the beginning, a large amount of solid solution strengthening elements such as copper and silicon to steel component is added to the developed steel. The urib is 6 millimeter and the joints of deep to deck were welded so that penetration depth becomes 75% or more of the plate thickness. Loading method, cyclic bending loads, load control, and stress ratio are equal 0.1. This is test apparatus. Repeated compressed stress is applied to deck plate by the actuator on the top. And repeated bending stress is applied to deck welded joints. Before results, I'll explain a definition of crack initiation life. This chart shows the strain measured by the strain gauges near the rib to deck welded joints. The strain remains constant value at the beginning, but the strain changes rapidly after a certain number of cycles. We think that the fatigue cracks initiated at this number of cycle. So the number of cycle when the gauge near the rib intersection is reduced by 5% from the initial value is defined as fatigue crack initiation life. This is an example of fracture surface. Fatigue cracks initiated from the most stressed part, transverse rib intersection. Finally, a result. This chart shows SN diagrams when the conventional steel is applied. Square plot shows experimental data. For the purpose of comparison with the developed steel, we calculated the lower bound in deep to deck to which conventional steel is applied. In addition, we set 1.5 times the lower bound of conventional steel as the target value of the developed steel. Finally, this chart shows SM diagram when the developed steel is applied. The initiation life of the developed steel is not less than 1.5 lower bound of conventional steel. So the crack initiation life was stably improved in deep to deck welded joints to which the developed steel was applied. Summary. According to fatigue test using USD's partial model specimen, the fatigue crack was initiated from the HAZ of the deck plate in rivet deck. According to fatigue tests using small specimen simulating rivet deck, it was confirmed that the crack initiation life was stably improved in rivet deck where the joint to which the developed steel was applied. Thank you for your attention.
Okay, thank you for your presentation.